Whenever you want.
Okay, so who's you gonna meet first?
Yep.
Okay. No. I'll do it. Você tem a descrição do palestrante?
Não.
Você quer deixar o palestrante? Eu vou chamar você.
Não, não precisa escrever.
No, it's good.
With different accent, please. With different accent, please.
With your French accent. Okay.
Bonsoir.
Bonsoir. Olá, pessoal, boa noite. Bonsoir. Bonsoir, tá bom? Bonsoir. Sejam bem-vindos. Como é que é sejam bem-vindos?
Bienvenue.
Bienvenue. Bienvenue, meus amigos.
Mon ami.
Mon ami. Bienvenue, mon ami.
Mes amis.
Mes amis. Bienvenue, mes amis.
I hope you have more than one.
I did. You and him, right? Like, at least two.
Yeah.
At least two is good. Okay. All right. Hoje nós vamos ter um francês que fala português, né? E um francês que fala inglês. Você vai dar sua palestra em português? Não.
Não.
Não. É uma pena, mas tudo bem. Né? Bem, boa noite a todos. Queria agradecer o pessoal que está nos assistindo online também. Boa noite. Estamos aqui para começar mais uma reunião do SouJava, né? De certa forma, apoiada, né, pelo QCon. A semana está acontecendo no QCon, que é um dos eventos de computação mais importantes do país. E, então, os palestrantes do dia de hoje são palestrantes do QCon. Estão vindo aqui para falar um pouquinho com a gente também, né? Eu acho que é muito bacana. Queria agradecer aos palestrantes do dia aí, né, por estarem aqui com a gente. Né? Thank you very much for you to come. E é muito bacana, né, a gente estar sempre podendo se encontrar, né? Então, queria também agradecer a Oracle por estar aqui, nos cedendo espaço, né? Na verdade, como o Helder é um diretor do SouJava, eu queria agradecer ao Wellington, certo? Que é o representante da Oracle aqui, então, certo? Wellington, por favor, vem dar as boas-vindas da Oracle aqui para o público. Então, uma salva de palmas para o Wellington.
Olá, pessoal. Obrigado, sejam bem-vindos. É a segunda vez que vocês estão terceira que está tendo encontro aqui. A porta está aberta, comunidade lá de Natal, Manaus também, então, porta aberta para poder...
Ceará.
Acompanhar do Ceará também, com certeza. E a porta da hora está aberta para a gente poder fazer esse encontro, esse bate-papo, e conhecer um pouquinho também da gente. Sejam bem-vindos.
Obrigado.
Chico.
Valeu. Eu sempre gosto de citar isso, porque o SouJava foi fundado em 1998, tem um bocado de tempo, né? A gente tinha 3 parceiros principais que nos apoiaram desde o começo, desde a fundação do SouJava, né? Que eram a Sun, a IBM e a Oracle, né? Eram os 3 parceiros principais. Hoje, desses 3 parceiros, 2 são Oracle, né? Então, eu acho que a Oracle sempre nos apoiou muito, né? Todas as nossas atividades a gente fez, sempre participou dos nossos eventos, e para a gente é uma satisfação estar aqui com vocês. Muito obrigado, Wellington, muito obrigado, Helder. E a gente, eu falei do QCon, eu queria chamar aqui as meninas do Dev Java Girls para virem dar uma boa noite também, né? Por favor, tá certo? São lá Helena,
boa noite, Thaisa.
E a Thaisa, a Helena que veio de Manaus, né, mas mora em São Paulo agora, a Thaisa que veio de Natal e que mora em São Paulo agora também. Então conta pra gente aqui um pouquinho, né, o que são as Dev Java Girls e o que vocês estão fazendo.
Então,
só um passinho para frente, não precisa tanto tempo atrás, né?
O Dev Java Girls é uma comunidade que surgiu com iniciativa para trazer mais mulheres para o mundo de Java, para trazer essa segurança para as mulheres que muitas vezes se sentem inseguras quando a gente vê nos meetups, que a maioria são homens. Então, muitas mulheres elas têm medo dessa aproximação, então surgiu essa iniciativa. Surgiu em janeiro deste ano.
Isso.
E
Já somos mais de 300 mulheres.
Mais de 200 mulheres na comunidade de Facebook.
Isso daí está
nesse início de organização, né, buscando fazer meetups, a gente já tem programado o nosso primeiro meetup para o dia 7 de junho.
Daqui a um mês.
Exatamente, vamos ter nosso primeiro meetup, já tem outro programado para julho já, e estamos buscando fazer grupo de estudo para as meninas também, programando lives para que elas possam acompanhar também. Então, mas a gente conta com o apoio de todos os rapazes, mas o intuito principal é que a gente possa trazer essa segurança para as meninas que muitas vezes ficam com medo realmente de falar em público, de perguntar, levantar a mão e tirar as suas dúvidas. Então, essas somos Dev Java Girls.
Então, divulguem para as suas colegas, suas amigas, divulguem e sigam a gente também. Vocês são
esposas, né? Tem várias esposas de Java aqui também. Né?
Estamos no Twitter, Facebook,
Slack,
então...
tudo @devsjavagirl.
Exatamente. E quem quiser dar apoio para a gente, a sua empresa aí que dá apoio para a gente, pode falar com a gente ali no final.
Obrigada. Valeu, obrigado.
Valeu, obrigada.
É isso aí. Certo. As mulheres dominando o mundo. Né? E é interessante que elas falando aqui, né, que as mulheres ficam intimidadas porque são coisas com muitos homens e tudo mais, mas é engraçado que vários grupos de usuários brasileiros foram criados ou, durante muito tempo, organizados por mulheres. Né? O SouJava, por exemplo, teve toda a sua formação aí, né? Teve mulheres como a Fabiane Nardon, como a Yara, né, que participaram desde o começo do grupo. A Karina, que é minha esposa, certo? Né? É tesoureira do SouJava desde 98, certo? Né? E foi a pessoa que organizou a maior parte dos eventos do SouJava. Então, a comunidade Java sempre foi muito bacana, assim, né? Sempre teve muita participação feminina entre os Java Champions brasileiros. A gente tem várias mulheres, né? Então, assim, acho que a gente está sinto-se super bem acolhidas, né?
Obrigada.
Porque, assim, eu sempre tem uma coisa que eu falo, assim, o pessoal fica falando assim, porque tem poucas mulheres na computação, né, e tudo mais, né? Assim, essa reclamação, né? Porque tem uma mulher na computação. Vou fazer uma pergunta para vocês aqui, não é para todo mundo, né? Quem aqui já participou de um projeto, certo? Onde você tem que trabalhar longas horas, certo? E você não consegue ver a família. Quem já fez isso? Projetos longas horas, não consegue ver a família e tudo mais, certo? Quem já trabalhou em projetos que é super estressante, que você chega em casa acabado e que você nem tem vontade de continuar fazendo? Quem já participou de projetos assim? Beleza. Agora, quem já participou de projetos assim, que você não consegue ver a família, você chega em casa acabado, você não tem mais vontade de fazer mais nada, não sei o quê, e pior ainda, o código nunca foi usado por ninguém, nunca vai para produção. Quem já participou de projetos assim? Certo? Né? Ou seja, projetos extremamente estressantes, extremamente inúteis, que não servem para nada, certo? A minha pergunta é o seguinte, não me surpreende que as mulheres não queiram participar de projetos desses. Tá certo? O que me surpreende é por que nós, homens, queremos. Tá certo? Então, a questão o que a gente precisa é a gente entender, né, que claro, tem um lado bacana a gente fazer essas coisas e tudo mais, mas não precisa fazer isso. Os projetos não precisam ser assim. Tá certo? E se a gente focar em trabalhar em projetos bacana, certo? Porque se você não aceitar trabalhar num projeto desse, certo? Assim como elas não aceitam, se você não aceitar trabalhar num projeto desse, o que acontece? As empresas vão ter que mudar e fazer projetos melhores. É óbvio. Porque sem vocês, elas não fazem nada. Certo? Então, elas só fazem projetos assim porque a gente aceita. Né? Então, acho que como comunidade, homens e mulheres, o que a gente precisa fazer é lutar por projetos que façam sentido. Pode ser difícil, pode ser estressante? Pode, tudo bem. Mas tem que fazer sentido. É história de projeto que não serve para nada, que você se mata a trabalhar e você sabe que aquele prazo não é verdade, você sabe que ninguém vai cumprir aquele prazo, mas ainda assim, você sabe que se cumprir não vai acontecer nada porque não vão colocar o projeto em produção de qualquer maneira. Esses projetos que você se sente o tempo inteiro e você se engana, fingindo que é um projeto importante, mas você sabe que não é, a gente tem que acabar com isso, meu. A gente é valioso demais para participar de projetos assim. Beleza? Certo? Então, com isso, né? Tem a mensagem oficial da Oracle, não?
Tem uma pessoa falando de mulheres aqui, tem uma pessoa representando o time de marketing da Oracle aqui, que briga o tempo todo e pode falar um pouquinho do que nós estamos falando.
Então, beleza, vem cá.
A Joana.
Joana, vem cá, Joana, vamos lá. bom, Joana? Como é que vai?
Tudo bom?
Muito obrigado por nos receber aqui.
Imagina. Estou muito feliz de dizer que, depois de brigar muito com a Oracle e com todo mundo aqui dentro, a gente conseguiu colocar no plano de marketing. A gente vai ter 25% dos eventos de developers voltados para mulheres. E, assim, não fechados para mulheres, mas eu quero ter mulheres falando sobre tecnologia e sobre desenvolvedores e tudo mais. Então, durante esse próximo ano fiscal, que vai agora de junho ao final de maio, a gente vai ter várias coisas legais acontecendo aí. É um prazer sempre receber todo mundo aqui. As portas estão abertas. Bem-vindos.
Muito obrigado, meu. Muito obrigado. É isso aí. É isso aí. Beleza? Nós estamos todo o pessoal que chegou depois, né? Muito obrigado por estarem aqui, né? A regra é não sentar do lado de amigos. Certo? Vocês já chegaram, essa é a regra. Quem estiver sentado do lado do amigo, muda de lugar, isso vai sentar do lado de não amigos, isso mesmo, tá certo? Pode sentar do lado de inimigos também, para você poder fazer amizade. Né? Mas não deixa o cara sozinho, o cara ficou sozinho lá agora, meu. Tá certo? Aí, isso aí, ó. Né? Aproveite para conhecer pessoas, porque essa é a parte mais importante. Tá certo? Ok? Tem a descriçãozinha do Jam, para poder anunciar oficialmente. Né? Nosso primeiro palestrante é o Jean-Luiz, diretor, Jean-Luiz, espera um pouquinho, quando eu falar, para você subir ao palco, sob uma salva de palmas, tá certo? Né? Jean-Luiz é diretor de engenharia da Tommy Tribe, é membro da Fundação Apache, arquiteto, altamente apaixonado por open source, tá certo? Então, eu queria aqui uma salva de palmas. Jean-Luiz!
Boa noite, eu sou João Luís Monteiro, João Luís Monteiro, os meus pais são portugueses, mas não está escrito em francês. De todas as maneiras, bem-vindos. Não vou dar a palestra em português porque não há muito técnico e não parece muita boa coisa falar em português para isso. Trabalho com uma empresa que se chama Tommy Tribe. E agora vou falar em inglês. Hello everybody, that was it. If you want, you can still ask your questions in Portuguese because I can understand quite well if you speak quite slowly. But for me, as it's mostly technical, it's way easier for me to speak in English because otherwise eventually it turns into a big mess because I keep switching from one to the other. So I apologize for that, and I hope that you enjoyed the talk. Small disclaimer. So I was speaking at QCon today. This presentation is mainly done for my CEO, which name is David Blevins. He's the CEO of the company. He was not available to come over in Brazil to give that presentation, so he gave me the slides and asked me to to use the QCon conference and then come over to give this presentation. So some of the slides are mine because I changed them. Some other are from David Blevins. So as I said in the introduction, I've been involved in quite a lot of projects. We do mainly middleware based on an application server which is named Apache Tommy. A while back when we funded the company, we had like a lot of customers coming over to us and say, well, your open source project is great. It works great for doing microservices, but now, well, how do I secure them, right? And like a lot of people at the beginning, we were like, well, I don't really know, so we'll get back to you as soon as we know more. And then we started studying security quite a lot, and we came into the security landscape, and eventually started to create an API gateway product, which really helped us growing in terms of security and in terms of background. Aside from that, before Tommy Tribe, I worked quite a while for a company in France, and I was like a lot involved in banking and health domain, so I'm quite familiar with PCI or with HIPAA compliancy, where the security is quite important. So that's the other reason why I'm here today. All right, so we'll be focusing only on the microservices approach. I'll be giving some details about the old architecture and why the microservices brings new challenges. And I'll be also giving you some options that I've seen so far in companies, and some options as well that we have studied. I'll try to give you some highlights about the JWT in the landscape, especially what it brings to Earth2. So basically, we're going to be looking at Earth2 before JWT, and then see how JWT helps in terms of architecture. And finally, I'll be trying to give you some insights about HTTP signatures, which is another standard. And I have a demo, if possible, maybe at the end. All right, the microservices for people a bit older like myself, microservices is pretty much SOA with a sexy name, I would say. It brings the same solutions. It has the same drawbacks, like, what is a microservice? Is it so micro, or is it like a bit bigger? Things like that. So basically, the issues we had with SOA, we have the same with pretty much the microservices now. So what we used to do before is basically we used to have like components. That's not something new. We were used to be professionals and try to package things as components, autonomous components. But previously, we were used to put all of that together into what I've called a system, a monolithic system, where you basically put all the components together, and then, well, they work smoothly this way. It definitely has some benefits. One of them is basically when you want to scale this, that's easy. You take the full block, you put that on the machine, and if needed, you will replicate that again. That works quite well. However, you don't really take the most of the CPU, for instance, because some services, like the small one, might be used way more than the other ones, and therefore you're going to be, really wasting some resources. It had also some issues in terms of, life cycle, because as we package everything together, the life cycle of all the components are basically tied together. So when you want to do like small changes into one of them, then you need to package the whole thing and deploy the whole thing, right? So that's a bit of the, a bit painful in that regard. Back to the security. There is an advantage to have like the whole application, is that when you want to secure it, you basically only have to secure the boundaries. And then obviously inside, when the components communicate with each other, they are already secured because there is no network in the middle, right? Obviously, if you start splitting, all of that into microservices, and you start deploying them into different containers, into the cloud with the network in the middle, then it starts to be more complex, because you have to secure all the microservices on their own, not only at the boundaries. And then you have, which is the hardest part maybe, you have to share the security context between calls, so that when you are at the fourth call, you still know who did the call at the beginning. So there are mainly two things to do when you want to do security on microservices. Is with the caller, you have to answer that question. What can you do? What permissions? And also you have to solve the problem of propagating the security context on the different calls, right? So the microservices, there are two perspectives in my opinion. I try to put like as many buzzwords as I could in that slide, but it doesn't matter. Basically, the microservices allows you to really take the most of your resources. You can scale which individual item. And you can also do more frequent releases. So there is another perspective, in my opinion, that's the organizational perspective, where that fits really well with the agile methodology, right? So the things are smaller, so you can do faster iterations, faster deliveries, etc. It's also more focused, so the teams are usually smaller, and it's HR proof. I don't know if you have been in big companies, but usually you've got like something which is for people-oriented architecture. Everyone wants to put a layer because that's another architect, and he needs to prove that it can be paid. So there is like a new layer every time. And also, as organizations keep buying new small organizations, etc., things keep moving, and therefore having small components gives you a chance to evolve more easily in that landscape. But on the other end, it brings new challenges. Today we're going to be focusing only on the security one. There are many things that we can say around the other ones, but 40 minutes is not enough to cover everything. For all the presentation, I'm going to be relying on one use case, which is this one. So basically, a set of users, 1,000 users. Every user basically has either an iPad, a cell phone, a computer, whatever device you want him to have, and then they do not crazy amount of things on their computer, but still they do 3 TPS. So that's basically a 3,000 TPS calls that we're going to do from external to the internal side of the company, and this is the gateway which does all the security enforcement, and that does the first security layer. And on the back end, we have again our microservices, and let's say that to deliver a service, we have in average to do 4 calls internally. So we're going to have this issue to propagate the security context, and we're going to have this, the issue to secure all of them. So that gives us 12,000 TPS on the back end. Is that okay with that? Yeah. If you have some questions, I'm happy for you to ask them on the flow, so that we don't have to wait until the end. But it's up to you. If you have questions, feel free to ask. So now, what security options do we have? Well, we have basic auth, right? Unfortunately, it's still on the landscape. Who still uses basic auth? Yeah, don't be shy. I know that most companies still use that. There is auth2, which has been quite well known during the, really is moving quite fast and a road to solve some issues. So we're going to see today what it solves in terms of issues. And then I'll be spending more time in this one, which is more the Facebook and Google way. So it's more common to find JWT when there is some kind of user, flow where you have devices and user typing username passwords. There is the Amazon way, HTTP signature. So that's what they usually use on their command line, their API basically. So when you're gonna, reserve some spot instances with their API, you're gonna be using that that one. And of course, I've seen many companies having their own security layer with their own rules, and I believe that that's probably 80% of the cases I've seen so far. And that's also why I want to share here some knowledge, because some companies tend to do in-house frameworks because they can spend time to dig into all those specifications, spend time studying them and see what fits best. And I think that's important to have the big picture. And probably much more, which brings us to this very nice quote that David Davis just picked up somewhere. The nice things about standards is that you have so many to choose from, and therefore, some companies cannot do the effort of digging into a lot of specifications and standards, so they say, well, let's go ourselves, let's do something specific so that it's easier. But in the long term, it's not always a good solution. All right, let's go to with basics so that we see what no one should do really. And then we'll see what auth2 really solves. So basic auth is very simple. This is an HTTP message, and the basic auth is basically relies on adding an authorization header with the basic scheme, and then at the end you just add a token. And guess what is the token? Basically a username, colon, password. Okay, you get all of that, you base64 encode that, and then you send that on the wire. But encoding is not encrypting, so it means that if there is someone in the middle that gets this message, you can go on the command line, do a echo token, by base64 decode. Here you are, you get the username and the password, right? So it's not really secured, and that's why you should not really use that, especially when you are invoking a lot of the APIs, because obviously if you start invoking the API 3,000 times per second, well, you're going to be having your username and password 3,000 times on the network, right? So you give more chance to the hacker to really be in the middle, sniff the network, and then grab the username and password, right? So that's definitely something you should adjust. And the other reason is that, you know, the more you want to scale on the front end and the more you want to have users to call your APIs, the more you're going to have to solve this problem of scaling LDAP, because LDAP becomes like a single point of failure. So if you want to increase the load here, you're going to be increasing as well the load on LDAP, right? Now on the back end, you know, there is still no authentication. So on the back end, you have many options. One of them is to do like IP whitelisting. That's an, you know, that's an option I've seen quite often in the companies. However, it's basically the enemy of you know, the elasticity, because you know, elasticity is like, I have a lot of, you know, I have the Black Friday, so I won't be paying for all those machines all the year. I just want to start, you know, scaling out this service because it's, you know, it's going to be used very a lot during the Black Friday, and when it's finished, I want to shrink down again, right? So the thing with IP whitelisting on the back end is that basically you have to have like a huge infrastructure team, because as soon as you start scaling up and down, they have to go and change the IP address every time, basically. So that's also why most companies don't do auth on the back end. How many of you do auth on the back end? Good. Yeah. Have you heard about the Target company in the US? Yeah. So the story behind this is that Target was doing the same. So they had like authentication on the you know, the boundaries, well, like all of us, they at some point needed some contractors, right? So they just got someone in the doors, you know, a contractor in the door, and that guy just started to connect to all those machines, do REST calls, get all the credit card numbers, and then started using them. So the you know, the security wall didn't came from this way, but it came from internally on the company, just because, you know, most of us have contractors and that kind of issue. So really, you should start securing your backend calls, just because, well, you don't know who is going to call them, right? So let's say that you want to use now basic auth as well on the backend. Well, then you start really having LDAP, which is burning. Just because if now you start having like more code on the back end, more users on the front end, well, then LDAP is going to die, and then your service is going to be offline. Right? So really, basic auth is not the best option for that. Another reason is that, you know, a hacker can basically easily do a denial of service attack, because he can make up any username, password, you know, pair. Very easy, base64 encode that, fire up like 100 EC2 instance, and then you are done. You know, you're gonna die because you're gonna receive a lot of bad requests, and you're gonna be killing your LDAP, right? So really, the LDAP is the single point of failure in this architecture, and the username and password as the authentication mechanism is definitely not a good idea. Right? So now what auth2 brings us. So auth2 tries to solve that issue of having the username password so often on the wire, right? So we try to avoid that, so that if someone is in the middle and gets the username password, you know, you won't be compromising all your account, basically. So how does it work? So basically, it consists of you know, the users that are basically going to exchange a username password. They're gonna get back a token that they're gonna store on their device. You know, if you connect to Twitter with your computer, you connect to Twitter with your cell phone. Basically, you're gonna get 2 tokens from Twitter, right? They're gonna be stored on each device. So what happens is that if you lose your cell phone, you can go to Twitter and say, well, I'm gonna just remove that token, and then, you know, the person which has the cell phone cannot use it anymore. And that's the good thing from auth2. In terms of how it works, really, well, it works the same way as we have been doing like for the last 20 years, I would say, with new words, because that's more sexy as usual. But you know, in auth2 terms, when you want to log in, you do a password grant, very sexy. But what you do is basically just do a post of a formula, which you have been doing for maybe 10 years or maybe even more, right? And you get back, so basically on the back end, you're going to verify the username, password on LDAP, and then you generate a token, right? And you store that token into a database, and you send back, to the user basically a pair, which is the access token and the refresh token, right? Those are blind tokens. You can see that as basically the primary key that points to the record in the database. That's the same. That's the ID, really. Okay. So basically, you post something, you get back a token, and what you're gonna use on subsequent calls is basically the token you receive, right? So don't forget to change the scheme from basic to Bureau, obviously. But then what you give is always the token, right? And then you keep going, can keep going and call, and then suddenly you get a 4-1. What happens? The token expires, right? So the access token expires, so now I have to exchange the refresh token that I receive, and I'm going to receive a new pair, which is a new access token, refresh token, right? So to do that, you're going to do a refresh grant, which is basically an exchange protocol again, where you give the refresh token that you received the first time with the access token. And then on the server side, well, you're going to be verifying that you have the refresh token on the database. And then if that's OK, you're going to generate a new token, a new access token, and a new refresh token, and you send that back to the user. And then the user, well, is going to use the new access token, right? Then you go this way, right? So what have we achieved with that? That was the goal. So we achieved to avoid having the username and password very often on the network, so that we don't give the hacker the opportunity to really listen in the middle and extract and reverse engineer the basic token to have your username and password. We replaced that with what I've called the blind token. It doesn't mean anything to the user. You can really see that as a primary key. So it can be a blind, timestamp. It can be whatever you want, but in any ways, it's kind of a primary key. And we have basically generated a lot of short-lived tokens because they expire eventually, and you have to refresh and get a new access token, right? But in essence, that's basically what we have been doing during the last 10 years, right? What happens when you have like a small application on Tomcat, right? You have a formula, you're going to do a post, you go to Tomcat, Tomcat under the cover is going to create an HTTP session, right? And what it gives you is basically the J session ID, which is the primary key to the map, where you have all the HTTP sessions, right? So all of that to say that auth2 really brings us some solution. But in the end, that's basically what we have been doing for the last 10 years, right? Obviously, there are a couple of things that auth2 also bring us, which are very useful. There are other flows, other grant types, which are very useful. But in the end, it's very important to understand that auth2, the password grant and the refresh grant, that's basically the same as how it works with the session ID and the HTTP sessions. I said at the beginning that microservices are basically SOA with a sexy name. Well, we could say the same with auth2. When you do a password grant, you do a login, a post. And when you get back a token, it's the same as when you get back a JSession ID, right? It's just a pointer. I'm gonna skip this one, maybe that's the detail. So basically what happens with auth2 is that, as I mentioned, if you have like 1,000 applications a day, that's when you're gonna send the username and password. And then every time else, you're gonna use only the access token. You don't need to send again the username and password. What's important in this one is that the username and password are not sent so often. So that's a win. The other win is that LDAP won't be burning now. So even if we increase the number of calls over here, we won't be reaching out LDAP so often because we only reach LDAP for the authentication process. But there are a couple of drawbacks, right? The drawback is that we basically moved the load from LDAP into a database, right? And the database has basically all the tokens. So it means that if you are running into a cluster, you have the same issues that you had with HTTP sessions with Tomcat. You're going to have to clusterize all the HTTP sessions, and then you have the exact same issue over here. So if you do like, also authentication on the back end, and you give, you send the token all the way through, and you pass the token through all the internal cores, then now instead of burning LDAP, obviously you're going to be burning the database, because all the backend services now are going to reuse the tokens from the backend, and then you're going to be killing your database, and eventually, the service is going to be offline again. So we solved a couple of issues. We introduced a new single point of failure, which is now the database. There is also a very huge impact. So I don't know if some of you worked in PCI or in banking or in hyper kind of thing. You did? So in that kind of environment, basically, every time someone does something, you need to track it. You need to have audit trails, basically. So if someone wants to read the card holder, you need to know who did that and when, basically. So what you do is basically on all those services, you're going to be logging, every time someone does something, you're going to be logging that token, right? So that you can, at some point, in 10 years from now, in the future, if someone wants to sue you, you can say, no, this person actually did that task. I did not, right? So guess what happens now? If you want from 10 years from now, prove that, this guy did, something on our system, it means that now we have to hold the token for 10 years. And if we want to keep that service running, then the database keeps growing all the time. And there is nothing you can do against that, right? You will have to store all the tokens, even if they expired and you don't need them anymore. But if you have to prove at some point that someone did something on your system, the only way you can match the token you have in the logs with the person is basically to look for the record in the database, right? So that usually performs very well at the beginning. Usually that's always the case. And suddenly customers start calling us and say, well, I cannot scale anymore because my database has like a lot of records. And then as soon as I do like a lot of backend calls, I'm killing my database, right? So that's a very important point. I've seen that very, very often. And we'll see now how JWT with R2 solves some other issues with that, right? So what are JWTs? Are you familiar with that? Did you heard about that? Yeah, a few? Okay. So it's pronounced JOT. Don't ask me why, I have absolutely no idea, right? They are called JOT, right? For old guys like me, it's basically the same thing as SAML, but a little bit more, let's say, less verbose and a bit more clean. It's basically, a JSON map where you have key value pairs. And then the good thing is that you can, sign that, and that gives you basically something that you sign, and you make sure that if you send that externally, no one can really change it, because when you get it back, you can check the signature. And if the signature changed, then you can just deny the access, right? You can encrypt some parts if you are, adding some critical information, some sensitive information in there. You can encrypt it, and the expiration is built in because the specification already has that. So how does it look now? So we had that token before, right? Now we get this. That's better, right? With that, we're gonna scale better, right? Maybe not. Wow, that's bigger, definitely. I agree. That's always a trade-off. When we do architecture choices, it's always a trade-off. So if we want to win in the back end and have a better service, we do have to lose that in some parts. Usually the tokens are bigger, that's for sure, because they have more information inside. We'll see that in a moment. But we'll see as well that it has like a lot of benefits. So if we zoom in, basically the first part, so first you can see that there are three parts in there. One which is the header, then we have a dot. This is the payload. Then we have a dot, and this is the signature, right? And all of this is basically base64 encoded. So it means that everyone on the network, including you on the server side, you can decode the header, you can decode the payload, and then you can check the signature at any time to see if someone changed and wanted to have, more roles inside. Let's say that someone gets the token, wants to have like the admin role. He will want to change this, but you can check with the signature that no one did that actually, right? There are a couple of claims. So again, it's a new word, new buzzword. The claim is basically the key value pair on the map. So you have a couple of claims which are standard. So the issuer. So if you have like Facebook and Google issuing tokens with the issuer, you can basically know if it comes from Google or if it comes from Facebook. And based on that, you can see, well, I'm going to use this key to check the signature, or I'm going to use this key to check the signature. So basically, that allows you to have interoperability very easily with external identity providers. Some others, like the expiration date, the issued at, and the GTI are also standards. 15 minutes, 10 minutes. So this is basically a summary of what I've done. I've said before. So there is a header, there is a payload, and there is a signature. And the signature part is what is really, really important. So again, this is a small change aside from the size of the token. I agree. This is a small change in the architecture. We just changed the token to be something more meaningful. When you read the RFQ specification, they say that we don't care about the token. You can choose whatever you want, but the overall flow is the same, right? So what we did is basically we switched from one token to another one. But it has like a huge impact, right? Because previously we had the token stored on the server side. Remember the HTTP session. And then we had the pointer, which was the JSession ID, which was sent to the client, right? So basically, the server holds the state, and the client holds the pointer. Now, with JWT, we basically work the way around. So basically, what we're going to do is keep the pointer on the server side and send the state to the client. It's easier to scale when you send the state to the client because you don't care how many clients you have. They're gonna keep tracking the state, and you're going to just be tracking the pointers of the server side. So that's the huge difference between the two. Thanks. So how does it work? Well, again, the RFQ specification doesn't care about the, the format of the token. So basically, it works the same way. You can still use your form, post your form to the server. The server is going to do the same. But instead of storing the token and sending the pointer, we're going to store the pointer and send the token, right? So indeed, the access token and the refresh token are bigger. That's fine. But on the server side, we only store the pointer, and we only store the pointer just for revocation purposes. But that's it. In terms of HTTP message, well, same impact. We use same authorization, we use bureau still, and we have the full token instead of the small one, right? So what happens in our architecture now? So we still have our 1,000 authentication per day, right? So our LDAP is still, having like 1,000 authentication per day. But now what happens is that instead of sending that small token and then look for the actual token on the database, you're going to receive the actual token, right? So you don't need to go to the database. The only thing you need to do is do the signature check. So the first thing you do is like you get the token. Okay, let's compute the signature again and see if someone changed the token or not, right? So for that, you only need CPU, right? So that's easy. That's easy to scale because now if you want to receive more requests on the boundaries of your company, you just need to add more machines. But that's only CPU, right? You don't need to scale the database. So the only thing you need to, you need the database for is basically when you do the refresh token. So you just need to make sure that, you actually issued the refresh. But again, if you have like half an hour refresh policy, which is usually the case, something close than that, then you're going to be eating the database like not even 1 TPS, right? So you won't be burning the database, you won't be burning LDAP, and even if you increase, the throughput over here, the only issue is basically to scale the gateway, which is at the boundaries, but that's very easy, right? You only need to do like RSA validation, which is not very CPU intensive. If you use something like RSA, what's very expensive and CPU intensive is really computing the signature itself with the private key, right? That's the critical part, and that's what you do only once at a time a day, right? But when you validate the signature with the public key, that's very fast with RSA. You can do a lot of that, which means as well that if someone wants to deny of service, do a deny of service attack, we'll have to make up like a lot of tokens with crazy signatures, and that takes more time than validating the signatures, right? So it's going to be harder to do. And well, if we want to do the signature on the backend, which again you should definitely do, you should definitely consider securing all the backend calls as well to make sure that you can track all the flow of the users. So if you want to do that, well, that's easy as well, because what you need to do is still keep the private key, and you can give the public key to anyone you want. Anyone that wants to check the token needs only the public key, and you can give this one. There is no security issue with that. And every backend call, basically, when you start hitting the backend call, you start validating as well the signature. And then if the signature is okay, then you get all the context for free from the token. So you know who is doing the call, what permissions it has, you have the email, you have whatever you put in the token. So you've got all the context for free, right? So if you want to propagate the context, which was one of the challenges I've mentioned previously, regarding the monolithic architecture, you get that for free with JWT, basically. Now, if someone wants to deny of service, as I said, is going to make up like a lot of tokens with a crazy private key. And obviously, when you're going to be checking with your public key, that's very easy. You're going to be denying, but no one can really deny of service this one, and no one can really deny of service this one. So we will remove the single point of failure. Is that clear? Yeah. So very quick introduction to the Amazon style. So Amazon has been using like message signing, which is another approach. Amazon is more doing again machine-to-machine calls. You are using their own API to do like EC2 operations, and therefore they use message signing. So they used to have their own specification. But one of the Amazon security guy basically came to IETF and created an RFC, which is HTTP signatures. This is a very, very, very simple, specification. I don't know if you are familiar with IETF, but usually when you start reading specifications, you start reading here, and then there is a pointer to another one, and then there is a pointer to another one, and then eventually you get back to the first one, but you forgot already. So you keep going, in circles, and you never get to the end. This one is very simple. It's about 20 pages, very, very simple, and it's very efficient for everything which is related to machine-to-machine calls. And also, it doesn't prevent us from having jobs as well in the messages, so that you can still provide context about the news, right? So now how does it work? Well, it works still the same way. So you still need an authorization header, but instead of using basic or Bureau, you're going to use signature. And then what you're going to do is basically, say I signed with the key which is named my key name. I use this algorithm. I sign those headers, and here is the signature that I computed, right? So one of the big benefits of HTTP signatures is that the secret never goes into the wire, right? If some of you use the EC2 console, basically when you create a secret key in there, basically it says make sure to store the secret key, because you cannot retrieve the secret key anymore from our system, right? So you go to the console, you generate that secret key, and then Amazon is going to store it. You have to store it. If you lose it, then you need to revoke the key, right? But you store it, and then you're going to assign all the messages with that secret that only you have and only Amazon has, basically, right? So that when the message comes in, basically, Amazon can look for the key, which it has because you gave him the name of the key, but it's not the secret, right? It's not a big issue. And then on the server side, he can look for the key, and then based on the headers that you mentioned over here, it can again compute the signature and verify if that's that matches or not, right? So the way it works is that basically what you do is that you take, well, I'll use this one, which is better. You list all the headers. The order is very important. And what you do is you're going to build what we call a signing string, right? So the signing string is based off the content length header. So you take the name, you take the value, right? You put that into a string, then you put a carriage return. Then you take the second one, which is the host. So you're going to use host colon API service.io. You put that into the string, carriage return. You do that with the date. You do that with request target. Request target is a pseudo header, which is basically the method and the pass. So you put all of those headers, right? That creates a big long string. And then with the big long string, and then the key that you have locally, you can assign it and send only the signature, right? So when the message comes in on the server side, what you have to do is basically build up that same big long string. You have the list of headers, you have the order, so that's easy. I'm going to read this header, I'm going to build up my big long string, and then you give the key name. So I can check the key on my database. Amazon can check the key, get the secret from it, and then compute the signature again, right? If that matches, then you are the people you pretend to be, because you pretend to be the people that owns this key. If the signature matches, you are the right guy. If it doesn't match, so either you are not the person you pretend to be, right? So you are trying to fake Amazon and give him, a key that you don't own, or basically you are trying to change the date, or you are trying to replay a message, or you are trying to change, I don't know, the host or whatever, and therefore the message is not correct, right? So that's a very simple specification that allows for very good security, and if you want to also, make sure that the payload didn't change, that's very easy. You can use the digest header. You compute the digest for the payload. You put the digest header over here. You add digest over here, and then you have also the security for the payload, so that no one can really change the payload, right? Because I don't want like someone which is going to to request like 1,000 spot instances, and I don't want to pay for someone else, right? So I'd rather have like the payload also signed. So that's the way signatures work. Again, one of the huge benefits of that is that you never send any password, you never send any secret. The secret, you have to go to the EC2 console, generate the key, and that's where you get the secret. Other than that, you never send the secret, you only send the key ID, and that's it. On the server side, Amazon is going to eventually look for the key on an LDAP or on a database, right? But the secret basically never goes on the wire, which is a very, very secure way. And same as for the R2 specification. If you use an RSA algorithm instead of HMAC, which is definitely possible, even if AC2 doesn't do that. But if you want to use RSA, you keep the private key over here. You can give the public key, and then everyone on the backend can really check the message, and you can make sure that no one is going to go in the middle and change the values of the headers or do some kind of replay attack or whatsoever, right? 40 minutes. I'm done. I have a demo. We can maybe meet after if you want to check the JWT demo, but we agreed on 40 minutes, so that's it for me. Obrigado a todos por estar aqui comigo hoje e espero que foi uma boa palestra para vocês. Obrigado.
próximo palestrante já vai chegar aqui, que é o Thomas. Deixa eu só fazer um teste. Se a gente fica melhor com o microfone ou não, por causa da transmissão. Fica melhor o microfone, vocês ouvem muito melhor. Vamos ver se o Thomas faz com... Sem microfone. Sem microfone. Com microfone. Sem microfone. Com microfone. Então, o Thomas só foi ali no Beiro Lavamão. Eu queria já, para as meninas do Java Dev Girls, ou Dev Java Girls? Dev Java Girls. Já, se vocês quiserem, já procura a Joana no final e já marca uma data para vocês fazerem aqui, a gente já queria disponibilizar. Né, Joana? Já deixa tudo em casa aí, no final já pode marcar uma data aí, a gente já faz um negócio bacana. Beleza? E aí eu tô aqui ganhando tempo, porque eu tô esperando o Thomas voltar. Ela vai falar, vamos lá. Pega o microfone lá. O cara tem uma dúvida. Fala, cara, qual é a sua dúvida? Pro Jovem, perguntas pro Jovem. Vamos lá. Pode fazer em português mesmo.
Posso fazer em português? Para usar o Signature valendo, qual é o custo que você tem para a Amazon para ela dar hold da sua chave?
O custo em CPU? O custo em dinheiro?
Existe um custo ou você tem que contratar um pacote e ele está incluso?
No, it's all included. That's the way it works with the API from Amazon. So you don't have any choice, basically. As soon as you want to use the Java API, you need at some point to get the secret on their EC2 console, and then when you want to use the API, you have to pass the secret in the API so that all the calls now are going to be secure.
Ou seja, mesmo que eu usar outra coisa, a Amazon fala
No, that's the one.
Ok.
Outras questions?
Mais perguntas? Já?
No caso do GWC, uma das coisas que eu percebi é que quando você tem a requisição, ela não valida no banco de dados, por exemplo, se aquele token foi utilizado ou não. Ele simplesmente...
No, o access token, we only check the signature. We try to make the access token as short as possible, so that if someone really steals the token, so first the account is not compromised, so you don't have to change your username and password. But you want to make the access token really be like 5 minutes or a few minutes, and then the refresh token is really the one which is going to change that short-lived password. I specified in one of my slides that basically the tokens are one-lived, short-lived, passwords. So you have to generate them very, very often, because otherwise there is a security hole, because someone can get the access token and really reuse it. Right?
Para isso, você pode usar o token bucket também, expira ele, tem um número limitado e evita DDoS.
There is one already?
No, go ahead. Finish.
There is something that I forgot to mention, but which is very important with the refresh token. There are a lot of basically implementations of R2 plus JWT. Most, a lot of implementations allow you to basically reuse the refresh token many times, request a new access token. We, on our API gateway, really avoid that, because someone that basically steals the refresh token can fork it, and now can get a lot of access tokens for it, right? So on our API gateway, what we do is like every time you use a refresh token, you cannot reuse it anymore. So basically, if someone steals it, you won't be able to make up like a lot of access token to then try a denial of service attack. That's something very important that you need to be aware of, and the implementation don't work the same way.
Obrigado. Bom, nosso próximo palestrante, ele trabalha na Red Hat, lá no projeto do Vertex, e vai falar um pouquinho para a gente sobre o React. Então, Thomas Sigismund. Thank you, Thomas. Sure. I will spend some time here. Alguém mais tem pergunta? A gente vai gastar tempo. Gente, aliás, é o seguinte, não vão embora, no final tem pizza, tá? Acabou de pedir pizza, tá chegando pizza aí. A gente pediu... Oi? mussarela, 4 queijos, frango catupiry, de Parma. Ó,
Tem minha Dev Girls aí, talvez elas queiram falar um tempinho também.
elas falaram no começo.
Nossa.
É que você chegou atrasado, cara. Você chegou atrasado. Tá vendo? A gente é tudo brother, cara. A gente pode jogar na cara, não tem problema. Então, mas fala aí, Otávio, o que você fez hoje no Kiko? Vamos gastar tempo aqui, enquanto o Thomas se arruma.
Pode botar piada, mas...
Não, fala aí no Kiko, cara. Trilha Java, o que teve lá?
Cara, foi uma trilha muito legal. Todo mundo ouvindo? Sim. Fala baiano, fala alto, né? O raça. Aí tem vários tópicos assim, né? O título foi Java moderno, Java hipster, né? Então, falou de Spring 5, programação reativa, inclusive aí os parceiros os três são do Kikon, né? Então foi Vertex, RX com Java, teve essa parte de microprofile, segurança com microprofile, os conceitos de GWT, persistência poliglota, né? Como o desenvolvedor Java utiliza isso. E para finalizar, teve um grande case de um cara que é o Itaú, né? Que estava usando lá aquele sistema legadão lá com... Nossa, qual é aquele servidor antigo mesmo? Mainframe, boa. Valeu, cara. Mainframe para utilizar umas arquiteturas mais hipster, né? Distribuídas com Kafka, com Cassandra. Todo esse tipo de coisa que a gente vê hoje e quer aplicar amanhã, né?
Não, mas não é só ser hipster, é questão da performance também, né?
Mas hipster é legal, né?
Tem que ter trend, né?
Tem que ter trend, cara. Próximo ano a gente vai botar, sei lá, blockchain com cloud
E containers, servers, na nuvem.
E Java 11.
No mainframe.
no mainframe.
Hi everyone, good evening. Thank you for joining. It's late evening now, and family is waiting at home, friends are at the bar, and you're still here. Thank you. So it's a bit cold with the AC. I got some cold tonight. Sorry for the voice. Tonight we are going to talk about reactive application with Eclipse Vertex. This presentation was originally 3-hour session at DevOps that my colleagues prepared for DevOps France last year, I guess. We only have 40 minutes, so we are going to cut a lot of parts and going very fast on some points, okay? But I will stay here until the end of the talk, so if you have any questions, just come to me while we're eating this good pizza. Okay, let's get started. I'm Thomas Sigismond. I live in France, in the south of France, in a city called Marseille. Maybe you know it, I hope. Great city, yeah. I work I'm a Vertex core team member since 2016, and I do open source for a living since 2012, thanks to Red Hat. I started to contribute to Vertex by creating a monitoring plugins, and then I started to contribute more and more, and then got the opportunity to join the core team. What are we going to talk about? We are going to talk about what is reactive, what is Vertex. Reactive is really a buzzword which we hear a lot about recently. We are going to talk about what was the reason why we want to do reactive, and then we will see how with Vertex you can make your different components talk over the event bus. We will skip the reactive programming part, otherwise it's going to be too long. So what's reactive? Who heard about the word before coming here tonight? Who heard reactive before? Never? No? Okay. A bit. Okay, just a bit. Okay, so reactive. Actually, you've been doing reactive for quite a long time. If you do spreadsheets, you are actually doing reactive. Okay, reactive is a way to create your program so that you define which transformation you are going to apply when an event occurs. And that's exactly how spreadsheet works, right? You enter some data in a cell, and then you have different formulas in the different cells. And so when you change the value in a line, then probably you have a subtotal which is going to be updated, and then another subtotal, and so on and so forth. Okay, one step after the other, you are going to update the different cell, and that's basically reactive. Is the way your system will react to an event. Okay, so why does it make sense to do that? Because nowadays applications have a lot of interactions, right? So we have been doing distributed systems and networking applications for a long time. If you have been doing some Java EE development or Spring development, or you probably have been working with a server and free tiers, you know, the browser, your server, and the backend database. So that's not something new. But nowadays, more and more you have more interactions, right? You probably not only talking to a single database, but maybe you have somewhere a NoSQL data store, or you are working with remote services. If you are selling products over the internet, maybe you will have to contact the shipping API from your shipping partner when you receive an order, etc. And the application, not only they have now many sources of I/O, but as well they have to answer to many different kinds of requests. It's not only the request for the systems, you also have to handle requests for metrics, for availability. You want to check the readiness of your application, the liveness of your application. And maybe you also have some asynchronous messaging coming from a messaging system. And those kind of requests, they have different characteristics. For example, you want to be able to reply to your readiness or liveness check availability, even if your manager just started to create the monthly report in the admin page of your application, right? So you don't want the application to not be able to answer this check if the application is busy building a big report. So reactive is a buzzword. It has a lot of meanings. We hear it a lot recently. Spring released Spring Reactive. You've probably also heard about sorry. You've probably also heard about reactive programming, reactive system, reactive streams. So let's look a bit at what this means in practice. So reactive systems, we're talking about distributed systems, and now we are going to build them so that they are resilient, fault tolerant, and scalable. Okay, so that's really at the architecture level of the distributed system. Then you have reactive programming, and this is really at the implementation level of the application. Reactive programming, it's a way to implement your application where everything is a stream of events, okay? And in this, you have more libraries like RxJava or Reactive Spring and Reactor. And finally, you probably also have heard of reactive streams, which is just a specification which allows different languages to exchange data over streams and manage back pressure. Okay, so that's really the reactive landscape. What's the the place of Vertex in all that. So Vertex, it's a toolkit to build reactive application on the JVM. Toolkit means that it's not, it's just a library, but you have to add to your POM file or to your Gradle build file. It's not a server that you have to download, okay? You can add it to an existing project. It's embeddable, so it does not force you to use a certain programming model. You don't have to create your whole application to be Vertex ready, okay? You can only use the features that you're interested in, and of course, you can start new application from scratch with it. And reactive meaning here that we are able to design reactive systems with Vertex. And we are going to see an example of a simple distributed application with Vertex. Vertex is polyglot. You can program some parts of your application or the whole application in different languages. We have Java, of course, but JavaScript, Ruby, Scala, Kotlin. Please notice that it's polyglot, but on the JVM. So when it's JavaScript, it's with Nashorn. When it's Ruby, it's JRuby. But you cannot do JavaScript and running on Node or Ruby and running on MathRuby, for example. If I had to summarize the Vertex philosophy in a few words, it would be just pay the right price. Yeah? We are in 2018, so to write an application that simply parses JSONs coming over an HTTP server and then inserting some rows in the database, we shouldn't have to start a server which takes us like 300 megabytes or even more. Okay. So we try hard to make a toolkit which will allow you to create fast application with a tiny footprint. Okay, we try not to mess with some problem which we think are not internal to mandatory to build an application. For example, class loading, dependency injection. You can do that with Vertex, but if you don't do class loading and dependency injection, you don't have to scan the class path to find all the beans which you want to start, etc. You go straight to the main method, and that's it. And also, we do not want you to have to import a full stack in your application. So it is based on a core library, and then you have a modular set of extension. We have, for example, Vertex Web, which we'll use in the demo, and it helps you to build a REST-style application. There is an HTTP server in the Vertex core library, but it's very low level. It's really to build a low-level HTTP servers. But if you want to make, like nice REST APIs, then it's better to do it with Vertex Web. We also have modules to do interactions with the database or NoSQL data stores, etc. So why do we want to do reactive? So think again. Sorry. In this example, we have a simple server which reads data from a buffer reader and checks the beginning of the line to see if there is the word echo. If there is this echo at the beginning, it will just write back the line to the wire, and we can also manage some other cases, and that's it. Does someone have any idea what these red blocks here are? No? No idea? Okay. So this is the thread executing the code, and those red blocks just show you when your thread is going to block. Okay? Why is it going to block? Because when you call bufferedReader.readLine, this is a contract. The contract says that the method will not return until you have enough data coming from the wire. Okay. Once you get enough data, it will return. Why could it happen? For example, you are communicating with a mobile phone, and mobile phones, it's not like the browser on your computer at home with a good DSL connection or even fiber. Sometimes it can be very slow or flaky. So, you know, that happens, and the data may be coming in very slowly. On the other side, when you're writing, if the client is slow to receive, then the buffers on your server will be full. And this method cannot return until there is enough space in the buffer to write the content, okay? So if you do that for an application which has like a few dozens clients inside your data center, it's going to be fine. But if you do that on a larger scale, then you will have bigger problems. Why? Because you are going to waste a lot of your hardware resources. Anytime you have to reschedule the CPU, the OS has to reschedule the thread, it comes with a cost. It's called context switching, and it's also lost to the performance of your system. On top of that, when your thread is rescheduled, you have no guarantee that the thread data which was before in the CPU cache is still here. Okay, it may have been replaced by another thread data, and now it has to refresh the CPU cache. So instead of going to the CPU cache, which is really fast operation, you have to go back to main memory. Of course, going to main memory is not something too bad as going to the disk or to the wire, but it's still completely different to go to the CPU cache, which is really fast for the CPU. Okay, so you might be thinking, well, okay, I'm not Google, etc. And I don't do this scale of things like thousands of connections, right? But how many of you here are talking about doing microservices for your enterprise application, or maybe not already, but you know, planning for the future? Yeah, don't be shy. Raise your hands. Okay, so half of the room. When you do that, excuse me. When you do that, usually you're doing that and you are going to create smaller applications and deploy a lot of those applications, right? Those applications are going to talk together. So it's like the application we saw before, where you will have a lot of interaction, a lot of inputs, a lot of outputs. And to be able to go fast and deploy fast, you will probably use a modern thing like Kubernetes and package your application as containers, right? The machines you get from your company, they are probably very good. They are probably have many CPUs and a lot of memory. But the share you have for the container, it's really a small fraction of that. Okay, it's probably just two virtual CPU if you're lucky, and a few hundred megabytes. Okay, and that's why reactive is such a hot topic today, because as we are going to move more and more workloads to the cloud, to containers, we will, even if we don't do things like Google and Netflix, etc., we are going to have more and more machines with containers with minimum resources. Okay. So how do we keep our thread busy? How do we make the most of our hardware? First, we have to keep the thread number of threads to a minimum and to minimize the context switches. And we also have to use a programming model which will make the thread always busy and stay working on the core. Okay. So for that, we are going to use non-blocking APIs. Okay. And instead of having the thread blocking the method, we will say, well, just do something else until the network is ready, for example. Okay. So Vertex and other system, who has been doing programming in the browser, for example? in JavaScript, Angular? Nobody? Yeah, quite a few people. So this is for example, event loop system. The browser, it's an event loop. With the JavaScript you write in the browser, it's only no blocking APIs, and then when you send an AJAX request, for example, you get notified later with a callback. It's the same with Vertex. So you have this event loop, which takes one event after the other and execute the callback on a single thread. Okay, but modern hardware still has, even if you only have two virtual CPUs, it's still two CPUs, right? So it would be bad to have in the process only one thread because you are going to use only one core of your system, okay? So what we do with Vertex is we create multiple event loops, and we are going to see later how that works and how you can write your application to make the most of the hardware. So we have this way of creating services or parts of your application as verticals. So what is a vertical? It's just a class which has to extend the abstract vertical class. Then you create a main method, you create a vertex object, and you deploy your vertical. Here it's an HTTP server vertical. You have this start method, which is the entry point of your application. When the vertical is deployed, the start method is invoked. And the nice thing with verticals is that Vertex guarantees that only one thread will execute that code. Okay? What does that mean? That means that in your class, you don't have to deal with synchronization, concurrent hash maps, etc. You're back to single-threaded code. So you basically remove a whole class of bugs from your system. You know, the nasty bugs of multi-threaded programs that you spend hours trying to debug, which are very hard to debug. If you have a single thread executing this, then you don't have those bugs anymore. Okay? So that's a lot of theory, maybe a lot to think. So we are going to try that in a demo. Okay? So, oh yes, sorry, I skipped. So just to explain before I show the code, what the demo is doing, we are going to build distributed system where we have one application, one JVM, starting an HTTP server with Vertex, and then we will have a reporting agent. So the agent will just, take some metrics from the system. Here it will be CPU and memory, okay? And it will also create an HTTP server. This one will make HTTP requests to the backend reporting agent. And after that, this system will send the data to the browser so that we can build a nice monitoring UI, okay? As we go through the presentation, we are going to make this evolve to use the event bus that we talked about earlier. But for now, it's going to be plain HTTP. So let's have a look at the code. It's available on GitHub, so you can fork it and try it yourself at home. Can you hear me? Yeah, okay. So let's start by looking at an agent. So as we saw in the slides, we are creating an agent class which extends abstract vertical. In the main method, we create a vertex object and deploy this vertical. Okay, that's pretty simple. Then in the start method, we get the monitoring system mbin from JMX, and with the vertex object, we are going to create an HTTP server but from there nothing happens. Okay. What we have to do if we want to be able to handle our request is to define a callback for what we have to do whenever a request comes in. Okay, so this is the request handler method, and anytime a request comes in, we are going to use the system admin to get the process CPU load and to get the use memory. Okay, we are going to put that in a JSON object and send it back to the client. Is that clear? The code is quite simple. Okay, let's start that. Okay, now we can try to invoke it. What was the port again? 8081. So I have my JSON object. Maybe it's better if I try to reformat it a bit. So I have a JSON object. The key here is a fabricated process ID, because with Java it's difficult to get the process ID. It's Linux. I could go to the proc file system and get it from proc self, but it's just a present demo, so we'll fabricate it with a new ID. Here we have the use CPU and memory. Okay, so we have implemented our agent. Now let's look at the server. The server is a bit more complex because we have to receive HTTP server requests from the browser, and then when we get a request, we need to send a new request to the reporting agent, take the result, and send it back to the browser. That's fine. So let's have a look. Again, we create the vertical, we deploy it with vertex.deploy vertical, and here we are using Vertex Web to create a simple API. Okay. This first part, I'm not going to talk too much about it. As we have static content in our browser, we have JavaScript to build the graphs, etc. We use a static handler. Basically, it's just a way to handle, take a look at the path of the request and get a file. Okay. The more interesting part for us is when we define a route to the dashboard path. So we say whenever we get a GET request on dashboard, we are going to send with the web client a request to the backend agent. And if this call succeeds, we get the response as a buffer, and we just send it back to the browser client. Okay. And then, of course, we have to create an HTTP server again, this time on another port, of course. And we set a new request handler. And basically, we delegate everything to the router. So the router object in Vertex Web, it's what helps you to define REST API. So you create your route, you say which methods you want to answer on which path, etc. So instead of like annotating a method and telling, okay, this is for a GET request on this path, you are basically doing this programmatically. Okay. So let's start this to see how that works. Okay, it started. So now, if I go to localhost 8081, no, sorry, 80, I can see my, so there is a lot of static resources. I said you have the HTML file for this page. And you also have, it uses a graphical library. And whenever we get the JSON from the intermediate server, we send the point and we draw those lines. Okay. That's not too complex. Do you have any questions so far? No, that's good. Okay, so let's continue. I will skip that. How long have I been talking so far? 20 minutes? How long do I have after that? No, don't know. Okay. Okay, I'm going to skip that part so that we can concentrate on event bus and the rest. So when you create a Vertex application, usually what you do is you create a main vertical, you give it some configuration, and then, as I said, you will organize your application by building small services, small components as verticals themselves, and each of them will get its own event loop. Okay, that's how it works with Vertex. So you have multiple event loops to be able to use all the cores of your machines, but you have the guarantee that just one event loop will execute the code of one vertical instance. Okay. But if we want to make the most of our hardware, especially if we are building HTTP servers, there's a nice way to do that with Vertex. You can pass some deployment options and tell, I want 3 instances of my HTTP server vertical. And what will happen? If you try with traditional Java APIs to bind the same HTTP server to the same port, you will get an exception telling you that the port is already used. Okay. Here, Vertex detects that you are trying to deploy different instances of the same vertical. And instead, what it will do, with the first one, it will actually bind the port. And with the second one, it will just say, okay, I will create a new instance of the class, aside another event loop. But then whenever I get a connection from an HTTP client, I will send the connection to one or the other vertical, okay? And the same for the third one. So that way you can load balance the connections coming in, and that's how you make the most out of your hardware. Is that okay for that concept? Okay? Cool. So then, when you create your application, of course, you can it's pretty usual to have like a front-end vertical for the HTTP stuff and a back-end vertical for talking to the databases, the remote services, etc. And depending on your needs, you can deploy more instances of one component and say, for this one I want 5 instances, and for the backend I just want 2. Or, well, it really depends on your typical workload, but it's very flexible. So far I just say I have a vertical and it gets an event loop, but actually it's more complex than that. If you think about Node.js, they started it all from scratch. So whenever they have to write a library to do database programming or HTTP clients, etc., they build everything from scratch, non-blocking. But in the Java ecosystems, we have tons of libraries which are really, really useful, and which we don't want to throw away, overnight just because we want to do non-blocking. Okay. So it's not a perfect world. We're not going to have non-blocking libraries tomorrow just because we want it. So we have this concept of worker verticals, which basically still guarantees you that just one event at a time will be handled. But this time it's not with an event loop, it's from a thread of a worker pool. Okay. So if you have, let's say, a library which does some APA calls or I don't know, interaction with the file system with blocking calls from Java AO file API, for example, then you can package that in a worker vertical and deploy it as a to the worker pool. Okay. There is also multi-threaded worker vertical, but it's here more. I don't like to talk about it too much because I would like to get rid of it actually. Multi-threaded vertical, it's really, it goes against the vertex philosophy. I don't know exactly why it was added. I have a vague idea, but I don't like it a lot. But it's more an anti-pattern. So newcomers, people who have more like a Java EE background and Spring background, when they come to Vertex for the first time, they see something like multi-threading and they think, oh, that's for me. I want to get the best scale I can from the hardware. So I need a multi-threaded vertical, but it's really, really a bad decision. So remember, that's an anti-pattern. So we said we want to avoid, doing synchronization, concurrent data structures, etc. But how do we make two verticals communicate with each other if we don't do that? But there's one way with Vertex. It's called the event bus, and it favors message passing. So your first vertical, in this example, we are going to do request reply. The HTTP server receives an HTTP request for details about the user. It will send on the event bus a message on an address, okay, user.db, and asking, please give me the detail for this user. The event bus will give the message to the consumer on this same address, and then the consumer, when it gets the data from the database, it can send it back to the HTTP server vertical. The address you are using, it's really plain string. It's not something complex like you can have in some messaging system, like you have hierarchical data. No, it's really arbitrary string. So you can write foobar like this, foobar like that, foobar like that. It will be seen as just any other string. We just saw request reply with the event bus, but you can also do publish subscribe. So every consumer will get the message. And you can also do fire and forget. So basically I send, but I don't care about the reply. I just send you the data. If you get it, it's good. Otherwise, I don't care. The message object, like in many other messaging implementation, you can add it some headers, delivery options for timeout. It has a body. The payload of the message can be anything standard on the JVM, string, integers, etc. But you can also send JSON, and if you have your own objects and want to do, I don't know, binary format, you can specify your own codecs. It works as well. How does that look from an API perspective? In your vertical, you will use the vertex object to get a reference to the event bus object. On the consumer side, you register the consumer for the ping address. So this is a ping pong example. I think you got it. You say, whenever I get a message, first I will print it for debugging, and then I will reply to this message with a pong. Pretty straightforward, right? And on the sender side, it's the same. In our vertical, we will use the vertex object to get the reference to the event bus. And since it's a ping pong, we are going to do that like once every second. And once every second, we are going to send to the same address. So this is very important. Ping address, a message ping, and here we have a special handler. You remember when we set the request handler, we had just one object, the request, and here you can notice that the reply object, which is here, has a succeeded method, and that is because this object is of type asynchronous result, and we have to deal with that because since something bad can happen on the event bus, the message there could be an error in any case on the transmission of the message. So you have to deal with failures as a first-class citizen in Vertex programs. So we are going back to our demo now. What we are going to do is, instead of invoking the agent with HTTP, we are going to use the clustered event bus, which spans 2 different JVMs. Okay, let's do that. So first, I'm going to stop the previous JVMs. Okay, that should do it. If I take a look at my push agent, can you spot any difference? No, that's normal. There is no difference. Okay. Yeah, I mean, the idea is to show you that you don't care from the point of view of the vertical if you are working with a distributed event bus or whatnot. What you are going to do is just using the event bus and publish a message, right? It can be local, it can be distributed. It's not your problem. Okay. So now let's take a look at the server part. So this time we don't have the web client like we had before to make the HTTP request. 5 minutes? Oh, okay. So we'll stop with this example. So when we get the request to the dashboard path, this time we don't use the web client. Instead, we're going to send a JSON object. And what does this? And what is this JSON object? It's a JSON object which will update. Okay, whenever we get a message from the backend agents. Okay, we are going to merge. We are going to start many agents, 1, 2, 3. Okay, we are going to publish the message. So anyone listening to this address will get it. And here we say, please give me the message for this address, and we will aggregate the results in a single JSON object, which will be sent to the browser. Is that fine? So this time, I'm not going to start it from IntelliJ. Because I need to start a cluster vertex. I'm going to use the Maven to build a fat jar. Okay, so that is started. And now I can just start my fat jar. And notice that I add a dash cluster parameter, which will tell Vertex to start in cluster mode. Okay. Too bad. What's wrong? Okay. Okay, sorry. I get it. That's not the right jar. I need to use fat.jar. Okay. So now Vertex starts with a cluster manager. Here we use the Hazelcast cluster manager. And we have to do the same with the server. So we're going to the same here. Create the file jar. And then dot it. Okay, so notice that now we detected that there are two members on the network. And if I go back to my demo, yeah, I get the data again. Okay, this time it's not with HTTP, it's with the event bus sending the data between the two JVMs. One thing which is nice with this model is that we don't have to know in advance the number of agents and where they are located. Because if you do that with the web client, you need to know an IP address or host address with a port. And now you can add as many agents as you want, and they will just pop up and send the data. So let's see that in action, and that will conclude our demo. And we will do that like this so that you can see the change instantly on the dashboard, hopefully. Yeah, please. Yeah, it worked. So you see we have now 3 members, we have the 2 agents, and we also have the HTTP server which receives the data from the agents. And then every time the web page sends an AJAX request to get the dashboard object, we rebuild the graph and republish it. Okay. So that's all we could do in 40 minutes. But I think it's cool, no? We have built with very few lines of code a distributed system, not very complex to read. Okay. Of course, it's simple. If you do something more complex, it will look more complex, okay, like in any system. But you see, it's really easy to build something which is distributed with a few lines of code. One thing which I just want to add before we end and go to questions. We do not manage the discovery of the member and the membership in the cluster ourselves. We use cluster managers, which are pluggables. Tonight I used the Hazelcast implementation, but we also have one with Zookeeper. We have one with Infinispan Data Grid. We have one with Apache Ignite. So you can pick something that you already use in your company and pick what you need. That's all I have. Any questions?
Galera, só uma pergunta para já ter para a próxima palestra, tá bom? Mas ele vai estar na pizzaria aí, então você pode interagir com ele depois.
Pelo menos um pouquinho.
I disagree. I was joking, so.
Uma pergunta, pessoal. Eu não quero fazer. Dou-lhe uma. Dou-lhe duas.
What about the testing and the debugging?
So, So, testing, we have a thing called vertex unit, because testing a synchronous program is effectively something difficult. So you can use vertex unit not only with vertex, it will work with any kind of asynchronous system. But what's nice is that it also has you some tools like when you have a callback, you can make some assertions on the callback and say, okay, make sure this succeeds and make sure that and make sure that the test doesn't end before the callback was actually invoked, things like that. So for testing, we're covered. For debugging, it's actually something you need to get used to. But if you've been doing some Java programming with executors, you're pretty much in the same situation. Except that here, it happens all the time. But yeah, there is IDEs are getting better at debugging synchronous programs, but it's really a work in progress. Yeah, it's a good point.
Thank you.
Pessoal, nossa última palestra do dia, depois da pizza, é o Leonardo Lima. Vai falar inglês ou em português?
Se vocês quiserem falar inglês, eu falo inglês.
Ele é brasileiro.
Mas eu moro nos Estados Unidos.
Desculpa.
Por isso que eu posso falar inglês. Mas eu posso, por isso que eu falo inglês.
Tudo bem. Nós moramos nos Estados Unidos. Fez um pouco de questões de serviço na nossa cara. Brincadeira. Ele trabalha na empresa chamada B2Com.
Empresa brasileira.
Que também é brasileira. Cara, a gente já se bateu há alguns tempos aí. Ele é do comitê executivo do JCP. Todo mundo sabe aí o que é o JCP? Não?
Eu falo rapidinho.
Então, você fala rapidinho? Ele é comitê de vários projetos da Eclipse Foundation também. Tava dois, né?
O Collections e o GenoCycle, a gente vai falar sobre o GenoCycle agora, daqui a pouquinho.
E com vocês, Leonardo.
É isso aí, pessoal. Boa noite. Obrigado. Então, vamos lá. Então, vamos lá. Então, JCP, ninguém sabe o que é. Alguém sabe que Eclipse é mais do que uma IDE? Não, além de mais do que uma IDE, né? Tem a Apache, tem a Eclipse, a JCP também é uma fundação, vamos chamar assim, o Java Community Process, onde a linguagem Java é definida. Então, a linguagem Java é um padrão que permite que várias empresas possam implementar, por exemplo, a mesma especificação. Então, por exemplo, no Java, a máquina virtual que roda Java, tem implementação da IBM, tem implementação da SAP, tem implementação da Oracle, da uma empresa chamada Azul, que não é Azul Linhas Aéreas, não é chamação Azul. Então, por ser um padrão, você pode aplicar, ter várias implementações diferentes, e com isso, você pode trocar de vendedor. E o Java EE, que até recentemente era Java EE, virou Jakarta EE, é a mesma coisa, um monte de padrões que você conta com ele para funcionar de um jeito, e depois as pessoas implementam esses padrões. Então, a empresa que eu trabalho, que o João trabalha também Tribe, é uma empresa que é uma vendedora de uma plataforma de Java EE, Jakarta EE agora. Eu participo, esse comitê, o JCP tem um comitê executivo para guiar o desenvolvimento dessas especificações. A Oracle, mais 24 empresas, a minha empresa é uma delas. E eu sou representante. Até foi onde eu conheci o Otávio. O SouJava também é um membro, uma dessas 24 empresas é o SouJava, que não é uma empresa, mas é uma entidade. Tem outras empresas, Twitter, IBM, Intel, e assim que eu fui conhecendo como participar de comunidade open source. Até 2013 eu nem participava muito, eu usava simples open source, mas eu não usava muito. E aí fui começando a ver como dá para se envolver, e aí também agora, principalmente depois do movimento da Oracle de colocar o Java EE no Eclipse, virando Jakarta EE, também me envolvendo bastante com projetos da Eclipse. Então, o Otávio é o líder de um projeto que eu vou falar aqui hoje para vocês, o GenoCycle, e outro projeto da Eclipse que eu também faço parte é do Eclipse Collections, que é uma alternativa ao Java UD Collections, né? Quando você vai fazer um list, um set, você pode fazer tanto com a classe padrão do Java, ou tem implementações, por exemplo, não sei se deve estar pequeno aí, mas aqui é Eclipse Collection, blá, 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 blá. E eu uso o Eclipse IDE, eu não uso J, eu não uso IntelliJ. Eu sou um cara velho e eu uso Eclipse faz, sei lá, 13 anos. Então, deixa eu abrir agora a apresentação. Isso é só o parênteses do JCP. Vamos lá. Então, I'm sorry if you don't understand our talk, but more or less, okay, it's almost like French.
Almost.
Almost.
Everything is in the almost.
Yeah. Então, essa é uma palestra que eu estava a gente gosta de... Eu vou fazer uma introdução que eu acho que deve até dar no final, mas eu gosto de fazer no começo. Quando eu comecei fazendo open source, é por isso que eu acho legal esse tipo de reunião com o pessoal que gosta de aprender coisa nova. Se envolver com open source é o jeito mais fácil de aprender coisa nova. E se envolver com open source não necessariamente é escrever código. Você pode escrever código. Tem pouquíssimos, eu falei ontem que eu não tinha nenhum commit, mas eu tenho poucos commits de código. Mas, por exemplo, se você ver aqui que está aberto aqui, do JNoSQL é a página Getting Started. Então, Getting Started é uma página, é um negocinho que gera uma página aqui, que o Otávio escreveu em inglês, eu estou revisando e vou contribuir a revisão em inglês. Se alguém quer contribuir com o projeto, lendo isso aqui, traduzindo para português, você aprende e contribui. Escrevendo exemplo, aprende e contribui. Traduzindo para espanhol, francês, outras línguas, aprende e contribui. Então, contribuir com o open source não é só escrever linha de código, ou ter vergonha de escrever linha de código. Eu odeio escrever linha de código porque tem que escrever o teste depois. Então, eu não gosto. Quem gosta de escrever teste, né? Mas quem tem interesse em começar a aprender, começar a se envolver, tem vergonha, tem receio de, não sou bom tecnicamente o suficiente, tem outros jeitos. Fazer palestra, até 2 anos atrás, o que eu mais fazia era palestra dos projetos dos outros, como o do Otávio. O projeto, eu não sei como é que a gente pode fazer, essa palestra nasceu disso. Eu conheci esse Game On aqui, eu vou falar agora, entrando já eu não vou me apresentar de novo na apresentação, o Otávio vocês já conhecem, não vou apresentar o Otávio para vocês. E eu conheci essa plataforma chamada Game On, justamente num dos Java Ones que eu participei, e eu achei que seria um casamento bem bom de como eu aprender microservices e como aprender no SQL. Porque eu sou do mundo SQL, e aí o Otávio era o meu guru, e eu, Otávio, como é que faz isso? Otávio, como é que faz aquilo? E aí eu falei, putz, vou aprender como é que funciona. Fiz essa palestra. Aí, se você quando a palestra é aceita, você se obriga a aprender, né? E aí fazer de verdade. Então, eu não vou falar de novo de microserviços, mas eles são usados para criar aplicações complexas, usando coisas pequenas, independentes, e comunicam através de APIs. E quando você vai começar, então, eu estou na empresa faz 13 anos, a gente faz IoT, a gente faz IoT industrial, ou seja, a gente pega a energia elétrica aqui da Eletropaulo, por exemplo, a gente faz leitura de medidor, controle da transmissão de distribuição de energia, passa pela nossa tecnologia. Nossa stack de tecnologia é antiga, a gente pôs isso em pé, usava o Java E5, 10 anos atrás. E aí agora a gente está fazendo, como é que o mundo faz software agora? Ninguém mais faz monolitos, um application server com 16 GB de RAM e rodando tudo numa pilha só. Então, microservices é super fácil, é o que eu preciso, o mundo está migrando para isso, vou aprender. Aí quando você começa... Peraí, ficou feio porque eu não fiz isso. Agora sim. Aí. Então, quando você vai começar a aprender alguma coisa, você procura lá no Google, né? Putz, como é que eu vou fazer? No Topic Tem, como é que começa microservices? E justamente o problema é, o pessoal faz parecer super fácil. Pô, faz um microservice em 5 minutos, roda 2 linhas de comando, faz um fetch jar, está resolvido. É a coisa mais fácil do mundo, você é muito ignorante. Cara, vou te ensinar aqui, vai ser rápido, você vai virar um mestre. Ou senão, eles vão te vender, faz um microserviço na minha rede. Então, ó, no caso, por exemplo, assim, você pode pegar aplicações de exemplo na loja do Bluemix, que é da IBM, para começar a usar microserviços. Aí você fala, poxa, é muito fácil. Eu vou ler tudo agora, isso aqui, e vou virar um mestre do microservices. E até uma pergunta que o João me fez, que você começa a pôr a mão, você lê e começa a pôr a mão, você fala, caraca, essa coisa é muito difícil. Agora, como é que eu faço o debug de tudo isso? Como é que eu garanto que a autenticação funciona? Segurança. Aí você começa a ver que as dificuldades são bem maiores. Então, quando a gente tem essa experiência negativa, muitas vezes a gente fala assim, poxa, eu sou realmente uma pessoa que não entende nada, eu vou ter que voltar para o meu mundo antigo e tudo mais. O Game On é justamente alguma coisa para te ajudar a começar com microserviços. Então, até, se vocês nunca ouviram falar, eu recomendo até procurarem. Se vocês, quantos de vocês aqui é velho o suficiente para lembrar daqueles RPGs de texto? Que você falava, entre na sala, procura, tá não sei o que lá, de texto, no BBS, lá, aquela coisa bem velha. Eu não sei como velho vocês são, eu sou meio velho. O Otávio fica jogando isso na minha cara toda hora. E, né? E aí, eu lembrava disso e falei, nossa, que legal. E aí, aí são projetos da IBM que eles usaram para ajudar você, mantendo a simplicidade do Hello World, você começar a trabalhar com microserviços. Então, a parte de infraestrutura, que é uma coisa difícil, por exemplo, eles já te dão e já te mostram como começar, e aí você vai criando seus microserviços, como a interação funciona e assim por diante. Você vai aprendendo, tem uma comunidade por trás, é bem legal. Então, por exemplo, eles têm uma coisa, eu aprendi no projeto, tem um 12 Factors, que é como é que você faz software as a service de um jeito que você tenha um bom código depois. Então, por exemplo, independente se é Java ou se é PHP, vai ter sempre code-based dependencies config. São as coisas que você tem que aprender ou tem que seguir para fazer um negócio decente. E aí, por exemplo, eu aprendi isso lá. Então, só de se envolver com um pouco com o projeto, a gente já começou a ver como melhorar e como criar projetos bons de microserviços. E aí eu vou entrar um pouquinho agora, porque isso começou. Quando a pessoa, a líder do projeto, começou a me explicar, ela começou a contar a história do Game On. No começo, eram poucos microserviços. Era um proxy, que recebe as mensagens dos mapas. Tinha um serviço que representava o jogador, um serviço que representava uma pessoa para criar o jogador. Então, quando eu falo, vou para a esquerda, esse cara me punha no room da esquerda. A implementação das pessoas é aquele room. Então, por exemplo, eu, como desenvolvedor iniciante, faço um room que representa essa sala aqui, que tem cadeiras, e você poderia escrever, sentar na cadeira A7, aí você senta na cadeira, e aí se outro jogador entrasse, você poderia fazer interação entre os jogadores, por exemplo. A infraestrutura é essa parte de azul, vamos chamar assim, são serviços que eles provêm, e aí eles usavam o MongoDB como base de dados, e usavam o Elk Stack para Elasticsearch, Logstash e Kibana. É uma pilha de logs, é uma pilha de software para gerenciar logs de processo de microserviços distribuídos. Né? E aí começou assim, o projeto foi crescendo, e aí agora é enorme. Tem muito mais microserviço. Eles mudaram a base de dados, usam Kafka, tem a parte de autenticação, tem a parte do mediador, o mapa, o que era o concierge virou mapa e mediador. Tem um cara para verificar quais são os rooms que ainda estão ativos ou não, porque como é uma coisa para começar, você começa, faz um room, depois o room some. Não paguei a conta da Amazon ou da Oracle, hosteando esse serviço, então ele some, ele morre. Então aí a gente faz o sweep dele para tirar ele de lá. Então, quando ela foi me explicar o que ela estava fazendo, ela me explicou justamente o assunto desses círculozinhos. A base de dados que ela tinha escolhido é o que ela sabia, e é o CouchDB, que é um tipo de dados, um tipo de base de dados de documentos. E ela falou assim, poxa, para fazer a representação do player do mapa, eu usei a mesma base de dados, e aí isso é um problema para mim. Por quê? Porque ela queria manter o mapa, como é um negócio de texto, ela queria manter o mapa 2D, igual que está na imagem ali. Você tem o centro, que é aquele first room ali, azulzinho, e aí depois você vai expandindo, e a ideia é que você... Se você faz uma coisa muito amorfa, fica difícil de navegar, então era mais fácil de navegar assim. Fazer isso em SQL ela acha difícil. Não sei quão difícil realmente era, mas ela falou, eu já sei CouchDB, vou usar JavaScript para fazer os rooms, vou fazer uma... E funcionou, só que ela descobriu que o CouchDB não apaga os registros, os documentos. Ele marca lá como deletado e não apaga nunca. Então a base de dados sempre vai crescer, 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 crescer. E aí, quando ela me falou isso, eu falei, beleza, tem jeitos melhores de representar isso. Aí eu falei, vamos então, me mostra como é que é a API de mapa. A API de mapa é bem simples, é um CRUD, é uma coisa que te dá o XY praticamente do room, e vai te falar, você conecta nesse lugar aqui para fazer qual é o serviço. Então, é bem simples mesmo, tipo, é um JSON que fala o nome, onde que você vai conectar para se conectar nesse microserviço, e as portas, né? Então, a ideia é que sejam rooms, tem portas nas dimensões cardeais, né? Norte, sul, leste, oeste. E aí a primeira versão que elas fizeram era bem guardado na base de dados do CloudDB, justamente o que era reportado, praticamente igual. E aí era bem difícil de falar qual é o relacionamento entre os quartos, porque a ideia é que do documento DB, normalmente você tem que fazer links de documento, mas aí se um apaga, como é que você mantém o documento linkado? E aí, para manter centralizado, ela pré-alocava os quartos vazios, e aí ela não tinha realmente como apagar alguma coisa. Para o meu trabalho, eu trabalho com coisas distribuídas, e eu trabalho bastante com coordenadas geográficas. Eu falei, olha, quando eu vou fazer mapeamento de rede, eu uso grafos. Por quê? Um mapa é uma coleção de... quando eu uso um poste, por exemplo, os postes da distribuição de energia elétrica são pontos. Todo mundo sabe o que é grafo, né? Bolinhas ligadas com risquinhas. Então, você pensar, são postes ligados com fios. É a mesma coisa. E eu falei, poxa, você tem o mesmo problema. Você tem bolas ligadas por portas. Eu falei, poxa, achei até, eu vou achar na internet para você uma representação gráfica, achei esse desenho lindo de alguém que fez, e ela tá lá, ó, tipo, A, B, C, como é que se conectam os pontos. Obviamente, dá para fazer uma coisa bem mais evoluída, bem mais com mais significado do que simplesmente só ligar os pontos, né? A gente tem, por exemplo, ela falou, poxa, me mostra. Eu falei, tá bom. Tá ligado ao seu primeiro quarto? Você fala, o teu primeiro quarto, ele é ligado a um porão, por exemplo. E aí você também pode colocar uma sala de jogos. E aí você tem um dungeon, né? Não é calabouço. Dungeon, esqueci, desculpe. E aí você pode falar que o first room conecta no dungeon, e o dungeon conecta de volta no first room. E aí o basement conecta no first room, e você não tem como entrar nele a partir do first room, você tem só do playroom. E aí você vai colocando justamente os relacionamentos. Então você permite fazer uma coisa bem mais complexa e representar essa complexidade bem mais interessante, pensando em um jogo, quando você faz um mapeamento como um grafo. Eu falei, beleza. Ela falou, nossa, que legal, vamos fazer. Eu falei, eu não sabia justamente o que era. E aí eu falei, como eu falei para vocês, né, normalmente eu uso para aprender. E aí eu falei, beleza, vou fazer com o Neo4j. E aí eu comecei a desenvolver, aprendi a plataforma do Neo4j. E aí eu já comecei a saber, putz, como é que eu vou fazer isso? Isso aqui tem um cipher per language, será que eu só troquei o SQL por CQL? Os CRUDs eram difíceis de fazer, eu tinha um objeto que apresentava o quarto, e aí eu tinha que ficar fazendo por reflection para fazer as coisas. Eu falei, mas em JPA era tão mais fácil eu fazer essas coisas. E aí no final eu falava assim, eu estava usando o CloudDB antes, agora eu estou usando o Neo4j, estou amarrado no Neo4j. E aí que meu colega Otávio falou, putz, estou trabalhando numa especificação que ainda não é final, que a gente começou isso, ainda não era nem público ainda, e que é o JNoSQL. Então, o que é o JNoSQL? JNoSQL é praticamente, eu vou falar, é a salvação, vamos chamar assim, para trabalhar com Java e base de dados no SQL. E porque isso permite que você não precise saber ou aprender 100% das complexidades ou das características, dos detalhes das APIs, das implementações de NoSQL. Acho que tem mais de 20 vendedores de NoSQL, né? Mais, com certeza. 250. E cada um tem um jeito de interagir com Java. Então, cada um tem sua API. Não tem uma API, como a gente sabe, não tem um SQL que funciona para todo mundo, como é no base de dados normal. E não tem o JDBC, nem o JPA, para a gente trabalhar. Tipo, normalmente quem está trabalhando no dia a dia não faz SQLs, coloca lá o objeto, bota @entity, @id e segue a vida. Quem faz create table? Só os velhos que nem eu. O que eu faço? Porque eu gosto de fazer. Então, a ideia do JNoSQL é justamente para evitar ou para replicar esse modelo do JPA, JDBC, para o mundo do NoSQL. Então, ele tem duas camadas. A camada de mapeamento, que vamos pensar que deve ser igual à camada do JPA, que é a camada que vai transformar seus objetos nas entidades de base de dados.
para NoSQL. Essa API tem o nome de Artemis. Depois vocês perguntam para o Otávio por que ele gosta tanto de coisas gregas, porque Diana e Artemis são a mesma entidade, né? A mesma deusa, uma é grega, outra é romana, né? E a parte de baixo, que é a parte de comunicação, chama Diana. Aí essas APIs são montadas de um jeito que você evita justamente ter que se amarrar a uma base de dados, assim como o SQL e o JPA. E a estratégia utilizada foi realmente dividir e conquistar, foi fazer uma coisa simples, focada para resolver o problema que tem que resolver. O Otávio, porque ele é muito hipster, ele fez um projeto na Eclipse, então é um projeto open source na Eclipse Foundation, atualmente em incubação. Eu sou um dos committers, mesmo não até nem usando tanto código, mas realmente há contribuições paralelas, por isso que eu fiz aquele preâmbulo no começo. A ideia é que a API é fácil de usar, porque ela replica as ideias que a gente já tem no mundo open source há algum tempo de configuração e sistema de estabilidade. E para cada tipo de base de dados no SQL, temos uma API específica de comunicação. Então, não sei se vocês sabem no SQL o suficiente, ou só ouviram falar, mas eles têm 4 tipos de base de dados. Tem a base de dados chave-valor, que é praticamente como se fosse um hash map persistido. Tem coluna de família de colunas, que o Otávio já me explicou algumas vezes, eu ainda não entendi 100% o que é. Tem o documento, que é o mais fácil, que é um JSON, né? É como se fosse um JSON lá. E a base de dados de grafo, que é justamente a que eu queria usar. E o Otávio, conhecendo base de dados no SQL, ele sabia que tinha uma API muito bem escrita, que é a parte de Tinkerpop, para a base de dados de grafo. E para as outras tipos de base de dados não tinha nada homogêneo, nada padrão. Era cada um no seu quadrado, literalmente. Era cada um fazendo do seu jeito. A ideia, então, é que essa API, esse framework, veio para unificar todo mundo, todos os tipos, para que você não tenha que ficar implementando contra cada um. Então, e também porque o Otávio é hipster, ele gosta de manter, e muito com razão, o que já foi utilizado de bom no Java. Então, entidades anotadas, usar templates para desenvolver, para não ter que desenvolver muito código. A ideia de configuração e repositório de outros projetos de sucesso foram mantidas, só foram aplicadas agora a esse contexto no SQL. Então, por exemplo, acho que todo mundo aqui conhece JPA, né? Acho que não precisa chover no molhado de @entity, @id. Isso aqui é JPA ou é NoSQL? É os dois. Vai mudar o import que você chama em cima. A ideia é justamente manter as mesmas nomenclaturas e ideias que você tem de como organizar o mapeamento de um código para a base de dados nesse sistema. Com essas anotações. Então, @entity vai criar o quarto, né, o site. @id vai ser o ID que vai ser gerado para dar unicamente. @column vai ser o nome do lugar. E assim por diante. Veja que se eu tivesse já implementado esse JPA e quisesse, agora quero testar isso no NoSQL, era só realmente mudar a dependência, dar no Eclipse Command Shift Alt para organizar os imports, ele arrumaria os imports e acabou, não tem nada para fazer. Então dá para você começar a brincar com isso aqui rapidinho. Uma outra ideia de um projeto que é o Nian, quando eu fazia os DAOs, aquelas classes enormes, generic DAO, eu sou muito velho. Aí eu tava vendo, não, você põe um template aqui, e aí você sai fazendo um monte de coisa fluente e está resolvido o seu problema. Sua lógica fica muito mais simples. Eu falei, caraca, velho, isso é mágica. Então, ali, por exemplo, a gente fez um serviço para mostrar qual que era o quarto que foi mais recentemente adicionado, para a gente poder colocar o próximo quarto ligado nesse. Então, ele falou, no template, você injeta um template, nem sei qual é a implementação desse template, eu faço aí tem um pouco do grafo, eu faço uma travessa, um jeito de percorrer, né, o grafo, vendo qual tem o atributo porta disponível marcado como true, faço um string, ordeno por um peso e pego o primeiro. Pô, velho, cadê o código que vai fazer o SQL disso aqui? Não precisa, já está resolvido para você. Fica muito mais fácil de ler e de manter um código desse do que manter um monte de strings SQLs ou CQLs, ou o que seja. Não que a ferramenta não suporte, isso vai suportar se você quiser fazer um caso bem específico. Mas a ideia é justamente ser muito mais simples do que a gente já tem hoje no SQL. Outra coisa que é um milagre do bem, você fala assim, poxa, eu quero então fazer o DAO, quero fazer o cara que vai procurar por nome. Você declara a interface, tá lá, site repository é um repository que vai retornar um site long. Você fala lá, eu quero buscar por nome, find by name. Depois você usa com arroba inject e fala que é um grafo, acabou, não tem implementação no código. Depois você não vai ter que mostrar o código. Depois vocês podem ir no meu GitHub e tá o código lá. Não tem implementação. O código ele é gerado automaticamente pelo framework. Porque justamente fazer DAOs é uma coisa de 10 anos atrás. Não, ninguém faz mais esse tipo de coisa. Ou por reflection e pelas verificações das anotações, a gente consegue criar esses métodos para você sozinho. Quando você tem alguma necessidade mais específica, por exemplo, para salvar, tem que ser transacional, porque você quer saber que salvou realmente, você pode usar anotações para marcar isso daí. E aí você, quando usa no seu DAO, você quer fazer o find by name, você só chama repository find by name, se você quiser, né, abstrair para evitar que o seu código de negócio fique dependente da biblioteca do GNOSQL, você pode fazer um cara bem simples. Tá? Parece mágica mesmo. Bem, aí a ideia é que, por que isso era legal? Não era só porque era uma base de dados de grafo, né? Era só porque dava para fazer coisas bem mais complexas quando você tem uma representação da base de dados mais rica. Você pode, por exemplo, ter, voltando lá ao desenho que a gente tinha antes, você pode falar, poxa, eu vou ter um item, que é o anel, que vai estar em algum lugar. E aí você pode ir mudando onde está esse anel, só mudando qual é a aresta. É bem mais fácil de atualizar. Você pode fazer ligações, atalhos. Então você pode criar uma porta nova, temporária, que você apaga. E aí são operações bem mais simples do que fazer com o documento ou com o SQL padrão que ela tinha feito antes. O documento que ela tinha feito antes. E você pode criar, por exemplo, sequências de uma coisa que eles queriam fazer muito, que não tinha como fazer, era criar sequências onde um empurra para o outro, e você tem essa ordem, ou esse fluxo de navegação garantido. Bem, então, esse aqui, a palestra é para mostrar um caso de uso da biblioteca de NoSQL, ou esse negócio de microserviços como o GameOn. A comunidade tem esse GameOnText.slack.com, que é justamente para onde você vai se envolver com quem realmente sabe de microserviços, vai te ajudar. O site para você jogar é o gameontext.org. O site da biblioteca é o genocicle.org. Esse exemplo que está implementado, que hoje não vai dar para mostrar o código, infelizmente, está no meu GitHub, quem quiser dar uma verificada lá. E é isso. Tem perguntas ou alguma dúvida que a gente quer comer, além do que qual sabores de pizza a gente tem lá fora esperando, que está cheirando para caraca? Eu vou estar por aqui também, se vocês quiserem bater um papo 1 a 1, eu estou aí, beleza? Obrigado, pessoal. Até mais.
Valeu. Pessoal, já está tarde, então vamos para pizza? A gente conversa aí. O pessoal do online que não vê não vai comer pizza, obviamente. A gente conversa. Manda por e-mail. Manda por e-mail. Vou tirar uma... É isso que eu faço. Eu faço abstratos, eu já só sei dizer para o Boa tarde, né?